Okay, so I got cut off. I wasn't paying attention to the time on the last one. Sorry about that. So let's go back to the vertical zones of the open sea again. We were talking about the different zones, how after you leave the coastal region, that we start naming the stratified layers based on the amount of sunlight that they get. So the very top layer is going to be your euphotic zone. In other words, true sunlight. They're going to have a lot of sunlight there. And in that area, we get about 40% of the world's photosynthesis happens there. But we always say that it doesn't necessarily have a high NPP per unit area. It said it's so big, we get 40% of the world's photosynthesis, but per unit area, you're not going to have as much, if that makes sense. And then you're going to have your bathyl zone. That's going to have less, and you're going to have then your abyssal zone, that's going to be even less, and you're going to have very low levels of dissolved oxygen in the abyssal zone, especially as compared to the euphotic zone. In the euphotic zone, you'll have a higher DO. Abyssal zone, you'll have a lower DO. And basically, in your abyssal zone, you'll have a lot of your filter feeders, or they call them deposit feeders as well, because they'll be feeding off of the marine snow. And marine snow is pretty much, they call that showers of dead and decaying organisms. Yummy. And a lot of your deposit feeders, and there's some particular types of worms that basically what they do is they eat the mud, and then they receive their nutrients from what the detritus had fallen in that mud. And there's a lot of your filter feeders down there. Your abyssal zone also is going to have your decomposers as well. And in this area is where you're going to have a lot of your chemosynthetic bacteria. Basically, those are species of bacteria that use the energy that's found in the bonds of the methane and hydrogen sulfide, and that's basically really deep in the ocean. And they use chemosynthesis then to generate energy instead of photosynthesis. Remember, it's so far down, so deep that it's not going to get any sunlight. This is also where you get, though, the bioluminescence. So the photic zone, a lot of the adaptations for the organisms there pretty much generate their own light. So that's kind of cool because it helps them feed in the dark waters. And there's some crustaceans, jellyfish, squid, and fish that will do that. And then we have upwellings, and that's basically where you have all those nutrients from, like the marine snow, for example, and the decomposers that are decomposing the dead organisms that have gone to the bottom. That is where you're going to have a lot of nutrient-rich water. And the upwelling is when you get that cold, nutrient-rich water making it up to the shore, like we learned about when we talked about El Nino. Primary productivity and NPP, there is, like I said, 40% of the world's NPP does happen in the open ocean, but as far as net, it is very dispersed. Okay, so here's another picture of the stratified layers again. And you can see here in your euphotic zone, you're going to have a lot of your nectonic swimmers. So pretty much your swimmers. And the abyssal, you see the anglerfish right here. You can see it's going to have its own bioluminescence. And this red line, it's supposed to represent thermocline. So you can tell that the temperature drops pretty drastically here in the bathyl zone. This red line is a much steeper slope than I shouldn't say steeper slope, but if you're looking at the temperature drop from here to here, you have a much more rapid slope per depth as you move in depth. Euphotic zone. Okay, now let's talk about some of the major characteristic of each individual zone. I kind of already did that, so I'll go fast. It's a home to a wide variety of your nectonic species: sharks, tuna, mackerel, jellyfish, sea turtles, seals, sea lions, and stingrays. The water temperatures are relatively warm. And remember, I told you also that they have high dissolved oxygen up in this layer as well. And some of the adaptations is that you're going to see counter shading. So in other words, the animals are darker on the top and lighter on their undersides, because that way if you're a predator that's looking up at a prey and the prey is lighter on their undersides, it's going to blend in more with the sunlight. And whereas oppositely, conversely, if you have a predator floating or swimming on top, when it looks down at the prey will blend in more with the bottom of the ocean. So that's why it's dark on the back. The bathyl zone, they call this the twilight zone. And by the way, you also need to know your nicknames. Let me go back and make sure you were able to see that. Euphotic is called the sunlight zone. Bathyl is called the twilight zone. And here, the animals, again, I remember I told you this is where you have the steepest drop in temperature, and that's where you have your thermocline. Animals must be able to survive cold temperatures, an increase in water pressure, and dark waters. This is where you'll find your octopus, squid, and the hatchetfish. These are some of the animals that are found in this zone. Adaptations, thin bodies that help them hide from predators, red or black in color to blend in with the dark water, and large eyes that help them see in the dark. And then the abyss, the midnight zone. Cold and completely dark with intense water pressure. Adaptations, some animals don't have eyes. Most of the fish in this zone don't chase their food. They're mostly filter feeders. They stalk it or wait for it to float or swim by, and then they are bioluminescent. They make their own light. Every time I try to do an animation, it shuts off, so I'm not going to do that. Human activities are disrupting and degrading marine ecosystems. Human activity heavily affects 41% of the ocean. No ocean area is completely unaffected. And then in 2006, 45% of the world's population lived on or near the coast. Now, the disparity here is that human activity, we said right now, is affecting 40% of the ocean with no area left untouched. But it's a single largely land-based species, human beings are, that are actually increasing and threatening this biological diversity. We are the one that are increasing the threat to biodiversity. And it's 71% of the entire Earth's surface that we are affecting in essence, because we are destroying the ocean. Basically what we're doing here is we're moving to the coast. I mean, it's nice to live there. It has water moderates the climate, so it makes it easier for us to sustain temperature changes. But unfortunately, the things that make the coast so enjoyable, we're destroying. By 2040, say up to 80% of the world's people are going to be projected living on or near the coastal zones. So basically what we're doing is we're developing the coast, we're destroying and polluting the coastal habitats, we're overfishing, because when we all go to the beach, we all want to go eat at the seafood restaurants. We are increasing runoff and non-point source pollution because of the fertilizers, pesticides, and livestock waste. We also have point source pollutions like sewage and cruise ships. That's a big one. Obviously, oil spills from oil tankers. We're destroying the habitat because of the trawler fishing boats. And for those of you going to Skidaway, we are going to use a trawler, and we're going to scoop up a lot of the organisms off the bottom of the ocean, and we'll dump them into a bin, and we'll basically look at the different species. Last year we got a pufferfish, and it was so cute, it blew up that we did throw it back in the water though, and it was fine. It survived, I'm sure of it. And then also we are introducing invasive species. Of course, some aren't, like the lionfish that's been found in a lot of the coral reefs in the Caribbean. They were accidentally brought over, and so remember, a lot of times it's not on purpose that happens, but that's going to basically deplete populations of the native aquatic species and cause economic damage. We have climate change because of our human activities, which is going to, in the end, increase the sea levels. It can destroy the coral reefs, because remember, the coral reefs have to be shallow enough to receive a lot of sunlight. And we already learned that coral reefs, remember, they have the equivalent of the rainforest, extremely high NPP and extremely high species diversity. What else? We're also increasing climate because of the fossil fuel burning, that also makes the oceans more acidic. And then we are polluting and degrading the coastal wetlands. And we already learned that the wetlands are extremely significant, especially when you go to Skidaway. You're going to learn this again. But those rivers are carrying the large amounts of nutrient-rich organic material. And therefore, we're going to get a lot more plants and algae growth. And those plants are in turn providing an ecosystem service for us by filtering out the contaminants out of the water. And then the salt marshes that we'll play in when we go to Skidaway are going to provide important habitat for the spawning fish and shellfish. 2/3 of marine fish and shellfish species will spend their larval stages in those estuaries. So y'all, estuaries are extremely significant. That's why it's important that y'all go down to Skidaway with us. Okay, let me see where else okay, so I already said all these. Cool. Coastal development, overfishing, runoff, point source, habitat destruction, invasives, climate change, and pollution. Oh, the end. Don't forget to do your cultural eutrophication storybook. Have a good day.